So officially there are three classes of levers that depend on where the fulcrum is placed and where the load and input or effort are placed as well. Or keep in mind that this triangle here is what determines or what identifies the fulcrum. Okay, but the key thing is that no matter what type of lever it is, the distances need to be measured to the fulcrums. So that might be a trickier problem that might show up later on, but these forces are all measured directly to that fulcrum as the reference. So what we want to do here to find the input force, okay, which is here in our formula, is to be thinking that the force times the distance for the input has to equal the force times the distance for the output. In this case, we don't know the input force, so we're going to leave that alone. That's going to be our variable. But the input force is being applied 6 meters away from the fulcrum. So we'll use 6 as this distance. The output force is whatever it is that we're trying to lift, which, since we're told the input force, this must be the output force. So that's going to be our 24 newtons. And then that is 2 meters away from the fulcrum. So that goes in there for our output distance. And then we would just do a little algebra. We might first do this math over on this side. So 24 times 2 is 48. And then this side just stays the same. And then we would divide both sides by 6. And we would find that our input force is 8. And our units per force are, of course, newtons. Then if I want to find the mechanical advantage, which describes sort of how this lever might be used, I would divide the output force by the input force. So now that I have those, the output force was given to me, that was the 24. And the input force is what I just found, that's 8. So my mechanical advantage is 3. And usually we are very picky about putting units on our final answer, but this is one number in physics that does not have a unit, so you should just state it as 3. Let's take a look at a second example. So here we have a first class lever. This is one where the input and the output are on opposite sides, or the load and the input are on opposite sides. And so what but again, that doesn't really matter. The key thing is that here is my fulcrum, and the distances are measured to that point, so we should be ready to go. We're going to figure out what the load is. The load is just another word for the output force. Okay, it's what we're getting out of this, what we're trying to lift using this lever. So again, we're just going to use that same formula where it is F times D, where we look at the in on the one side of the equation, and then F times D with out on the other side. And our input is what's known this time, and that is 2 meters away from the fulcrum. So the picture is really helpful in setting up our equation. And the output is the thing we're trying to find, our load. And the output distance is 3 meters. So again, we'll do a little algebra. Let's clean up the left-hand side. 12 times 2 is 24. And then we're going to want to divide both sides by 3. And we would find that our output force, or our load, that green box, must have a value of 8. Okay, now this is going to be something that is measured in newtons again. I think that was our answer on the last one too. It's not always 8. All right, and then when we calculate our mechanical advantage, we will take the output force, and we would divide by the input force. We compare what we're getting out to what we're getting in. And the output was 8, and the input is 12. Really important to do that in the right order. And you could either write this as like a reduced fraction, or you could grab a calculator and you could give it as a decimal. Either way is fine. About 0.67.